Hello and welcome everyone to episode 3 of our webinar series, Bridging the Gap, Indigenous-Led Clean Transportation for Saskatchewan's North. This is brought to you by Aurora Renewables and English River First Nation in partnership with Natural Resources Canada. I'm Mitch Carlson and I'll be your host and moderator for today's session. I'd like to begin by acknowledging that many of us are joining from the ancestral lands of the Cree, Saulteaux, Nakota, Dakota, Lakota, and Dene people, as well as the homeland of the Métis in Saskatchewan. If you are new to this series and missed our first 2 episodes, or you would like to rewatch, you can find recordings on Aurora's YouTube channel. A link can be found on Aurora's website where you registered for this webinar, and we'll also drop that link into the chat. Today, I'm pleased to have with me Kenneth Becore, creator, producer, and host of the YouTube channel, The EV Revolution Show, who will be presenting an EV 101 session as an introduction to electric vehicles. During the session, we will be monitoring the Q&A and chat function, so please feel free to ask any questions along the way into the chat box, and we'll take some pauses throughout the presentation and try to address as many questions as we can before the end of the session. But because I know that Kenneth has a lot of valuable content to cover in the and a limited time, Kenneth, I'll let you take it away to introduce yourself and to jump right in.
Great. Well, thank you very much. A pleasure to be here and welcome for everybody. And I appreciate you taking the time to join us on this webinar. So let me just grab my screen here and share the screen. Hopefully you are seeing the full screen of the presentation. Is that correct?
Right now, now it is. Yeah.
Okay.
Thank you.
Excellent. All right. Well, thanks again for that. I'll get right into it. As Mitch said, I am going to talk and give you a foundational quick session, which is something I could usually do in a couple of days. So I'll try to cram this into the next 30 or 45 minutes of understanding about EVs, what they are, what they're all about, and what are some of the advantages that they can bring you from a consumer perspective. As Mitch said, my name is Kenneth Becore. I wear many hats. I'm just wrapping up a 40-year IT sales career and now getting more into the EV landscape. I've produced and host and created a YouTube channel that I've been running since 2018 called the EV Revolution Show, which you can find that. I also do audio podcasts that follow the similar name, EV Revolution Show audio podcasts. So you can find the audio on most of the major audio platforms. And it's really to help educate consumers about electric vehicles. So it's not a business for me, it's all a passion project. I also volunteer for the Electric Vehicle Society of Canada, and I run the Caledon chapter here just north of Toronto in Ontario. And so I'm very active in the community and going out and talking to a lot of consumers about EVs on how they could work for them. You'll find for me that I keep it real. So, yes, I'm passionate about EVs, but I also understand that they may not work for everybody or every situation. So, my purpose is really to help educate consumers about EVs so that they can make those informed decisions if they want to look more into EV. So, I'm not here to convince anybody, it's to educate folks. And I'm also right now a part-time instructor for Humber Polytechnic College here in the Toronto area, where we're just wrapping up a pilot program for an EV Essentials course that they've been running. So I'm one of the facilitators for that course, where we again teach people about EVs. We do some technical stuff, we do some fleets, we talk about a lot of the technologies around EVs. And because I want to take what I do here seriously, I am a member of the Automotive Journalists Association of Canada, AJAC. You may have heard of them on commercials or at car shows and see some of the awards that we give out. There's about 120, 130 of us across Canada that cover the automotive marketplace, and I'm also part of the similar organization in the US of the APA. And it gives me access to press fleets and to vehicles and information. And sometimes I'm invited to the auto manufacturers' events where they'll bring out new vehicles. And I focus strictly on plug-in vehicles. So for this presentation, when I talk about EVs, I'm talking about any vehicle that you can plug into the wall or into a charger outlet, not mild hybrids or hybrid-only vehicles. Just want to make that distinction. Again, I am called upon sometimes as an EV expert. I'm very humbled by that. I know there's a lot more smarter people than me out there, but I do try to stay knowledgeable and I do try to report and analyze and talk about stories and keep it real again to consumers. So I have been on CBC a few times, the Global News. I've been on various radio stations in Toronto and in BC as well, just to help spread the word and help answer questions to consumers. I want to start with a quick history lesson. Many folks out there may not realize that EVs actually go back quite a long ways. And the first EVs were invented in 1838 by a Scotsman named Robert Anderson, where he took, the existing battery technologies at the time, like a 12-volt type systems, and put it into a small vehicle, calling it the electric carriage, basically in lieu of the horse and carriage, and telling people that this was a better way to get going. And as you can see, even folks like on the bottom left of your screen, Mr. Thomas Edison there, who was involved in the EV landscape in the later 1800s. Here's a picture of an EV that's doing a 1,000-mile endurance run to prove that EVs could have that capability. Now, it doesn't mean that that EV had a 1,000-mile or 1,600-kilometer range, but it meant that they were able to show that that vehicle could do that in some environment where there's some charging network or something involved to help it do that. So a lot of back and forth on EVs over the 100 plus years, excuse me, almost 200 years now. But unfortunately, or fortunately, whatever way you look at it, of course, ICE vehicles became the prominent mode of transportation because of the mass manufacturing and so forth, and EVs kind of got relegated back to not much going on. Really, it's only in the last 15 years or so that we've seen the resurfacing of EVs and to being where they are today, being more mainstream, and we're now at the mass adoption phase of electric vehicles. There are, of course, a famous EV. I think many that might have gray hairs, like myself, might remember the lunar rover that the Apollo missions back from the 60s and 70s used to explore the lunar landscape. Again, there is no oxygen to breathe on the moon, so an electric vehicle that's powered by solar, in this case, sunlight, that would charge the batteries and move that around. I bet eventually, we are trying to get back to the moon in a manned capacity. I'm sure that if you went there and replaced the batteries, that it would just start going again. Keep that platform, keep what you see there in mind, because I have a couple of slides coming up to talk about EVs, and you'll see a lot of similarities between what you see here on the screen now and what I'll talk about in a little bit. But they've been around for a while, and we obviously have many modes of transportation, modes of fuel. And I think where the world needs to get to in more capacity is the all electric and even plug-in hybrid electric solutions. Um, just, to set the record straight, internal combustion vehicles are not going away anytime soon. They will be around for decades and decades and decades. I mean, 50 years, 100 years, I can't say, but a long, long time. A lot of countries, a lot of regions of the world will not have the ability to even look at transforming to electrification for many, many years for many reasons. And we have in the Canadian fleet of light duty vehicles, these are vehicles that are owned by folks like you and I, that consumers drive, somewhere around 26 to 28 million of those vehicles that are on the road today in Canada. We only have about 1.5 million plug-in vehicles on the road in Canada today. So we have a very small subset of the overall number of vehicles that are in use today by consumers across Canada. Those are plug-in. So there's a lot of growth potential, and it's going to take a long time for those vehicles to slowly transition out. And some people, no matter what you say, may transition to all electric or plug-in hybrid or even want to. But these are the options, and obviously they make better sense when you go to all electric because of cost and emissions and things like that, which I'll talk about in a little bit. But for simplicity purpose, just visualize and understand that an electric car is just a car that's propelled by electricity. And the motion that moves the vehicle is done by an electric motor. It could be one motor, it could be two motors, it could be multiple motors, depending on the vehicle and the manufacturer. Any same electrical motor that you'll get in a radio controlled toy or anything that has a little motor in it, a motorized toothbrush, whatever. It's the same type of motor. Obviously, they're just scaled up to handle more weight and more power. But it's the same principle, having something that spins because of magnetism and electromagnetic force through it. Energy is put through it, and it spins one way to go forward, and it spins another way to go backwards. And picture that. It's a very simple approach to moving a vehicle, and the energy is provided by batteries that are stored in rechargeable batteries in the vehicle. And one thing that you notice into an EV, especially all electrics, is that instant torque. There is no lag for an engine to spool up to get to their optimum torque and horsepower levels. You get that instantaneously when you depress the accelerator in an EV. If it's rated at 200 horsepower, you get 200 horsepower instantaneously, and so forth. So strong instant torque, strong and smooth acceleration as well. Here's an example where GM tried to bring, kind of tested a little bit of the EV landscape in the late 90s with the EV1. Again, underlying that principle. Now, the EV1 at that time was still based on 12 volt technology, which is different than we have today. And what we have today is this platform. So remember, I mentioned to kind of keep that visual of the lunar rover in your minds, and it's not that far from what we see here on this screen, where we have this skateboard platform. It's basically and I'm a big product of the 70s, even before the 70s, but I remember skateboarding in the 70s and it was a lot of fun. But it's a very simple platform. I've got a couple of axles with some wheels. I've got this flat floor between them, and that connects it. And that's basically what most EVs are today, especially EVs that are built from a EV platform, like in the lower right, where you see the PPE, or the premium platform electric from Audi, and shared with a lot of the VW Group platforms. That it's really just a simple platform that has the battery pack as its floor, and then you have a couple of axles. This example is showing those red components. Those are electric motors. And this happens to be an all-wheel drive because you have one in the front, one in the back, but you could have just one in the front for front wheel, one in the back for rear wheel drive, and so forth. You've got some electronics, some controllers, some power distribution modules, and things like that, as well as some of the components. And then you have your standard hydraulic brakes, and whether disc and drum. You have your standard suspension systems, whether it be, hardware-based shocks and coils or air suspension, and some other components, but that's it. In an EV, you typically have around 20 moving parts. That's it, about 20 moving parts in a vehicle versus a couple of thousand in an internal combustion vehicle. And that's significant, and I'll tell you why in a sec. So just picture that platform, and then the chassis would go on top of it. But these platforms allow manufacturers, like in the picture in the lower right, to produce different kinds of vehicles based on these platforms. I need a longer vehicle, a big three-row SUV, then I just extend the battery pack, adding more cells and modules, make it longer, and there's my three-row SUV. I need a compact car. I take some modules and cells away, I shorten that pack, and now I've got my subcompact with still using a lot of the same components. And that's where we've seen the industry move, is to this very simple approach to the architecture and to manufacturing, and they can reuse a lot of the same components in multiple kinds of vehicles. So again, internal combustion car, that's typically what it looks like under the covers. The picture might not show it, but there's a lot more obviously moving parts, and there's a lot more parts there where it comes to an engine, to a transmission, to a drive shaft, to your fuel tank, to your exhaust system, and all those kinds of systems that are in there. None of those are in there in an EV. It's a very simplified platform again, where you have some electronics, some wiring, some distribution, your power from your battery, and so forth, and your motors that actually move the vehicle back and forth. I'm going to quickly talk about some of the EV advantages here, total cost of ownership, some safety, charging, and how they're greener, because there's a lot of fear, uncertainty, and doubt, or FUD out there. You may read a lot of media reports, you may see things on social media or on mainstream news. I find that they tend to just report or talk about one side of the coin, and it's always good to get a balanced approach to looking at information, especially when it comes to EVs. I just want to pause here, Mitch, for any insights from yourself or anything to add at this point.
Thanks, Kenneth. Yeah, just monitoring the chat right now. So far, no questions in. I know you've got a lot to go, so let's just keep on rolling. I've got a
Yeah.
couple questions coming in through a different platform, but we'll hold them till
Okay.
the end here.
Okay, great. So I'll keep going and talk about that. So when you look at total cost of ownership, a lot of the information I hear is EVs or like all electrics are too expensive. I remember doing a radio talk show in BC, and four out of the five people that came on said, "Well, all electrics are for the rich," and that's simply not the case. When I look at the price points of EVs today, when I started covering this market, there was about 15 or so models and trims that you could purchase in Canada that were all electric. That was back in 2016. Today, there's about 260, 270 different models and trims that you can buy in Canada today that are all electric. The amount of choice that we have as consumers has astronomically increased within a decade. It's been a crazy growth. So, and a lot of those prices, probably about 75 or 80 of those, almost half, are lower than the average vehicle price that consumers pay in Canada. Last year, the average light duty vehicle price was around $68,000. And there's a lot of EVs that are under that price. There's a lot that are over it as well, but there's a lot of choice, great choice for consumers that are under those price points. So I would argue the fact that people say that they're just for the wealthy. We have things like incentives. We have the new EVAP program that was announced federally by the Liberals back in February that has started this month, which can offer up to $5,000 off vehicles that qualify for under $50,000. It's there to try to help the lower end of the market for people to get into EVs that might find 65, 75, 60,000 challenging. I mean, 50,000 is a lot of money. I get it, folks. So anything to help lower that initial price point is a good thing for consumers. But you also have to look at things like fuel versus electricity costs. I mean, right now, fuel is center stage, right? With the geopolitical situation that's happening around the world, we're seeing gas prices soar again. And that's becoming front of mind for a lot of people. Maintenance as well for EVs are much lower, partly because I just showed you briefly that their platforms are simple. There's not a lot of stuff there. And with only 20 or so moving parts, the amount of parts that could fail is much lower in an EV than it is in an internal combustion vehicle that has over 2,000 moving parts. So typical maintenance costs are much lower. Insurance costs can be lower. I stress the word can. I mentioned at the beginning that I try to keep my facts real. Not all the time is auto insurance lower in an EV. Auto insurance is extremely subjective to an individual or a business entity, depending on who's getting the insurance. So it's really hard to generalize anything from the insurance company. And each province, each insurer across Canada is completely different on how they approach EVs. So if you want to put that to the test, I would encourage you to get a quote from your insurance company on a new gas car and get a comparable EV car. And I'll show you some comparisons coming up and see what your rate would be, just to see if it would be lower. Because in a lot of cases, it could be. And then, of course, the ability to home charge is something that you can't do with gas cars. You can't fuel up your gas car at home unless you have your own fuel tank, and you might have that situation at work or in a commercial setting. But it's very hard to do that from a consumer. So home charging is something you can do if you have that ability for electricity at home. Here's a CA slide from a few years ago that talks about annual operating costs and gives you a per cents per kilometer type of idea. And the takeaway from this slide is that the Toyota Prius, which is kind of held at the highest standard of affordability for lowest operating costs, you can see that it comes in at about 7.5 cents based on this data of 18,000 kilometers a year at almost $1.30 per liter of gas. That's a really good operating cost, right? To keep your cost per kilometer at under 10 cents is really good nowadays, especially. Well, here's a snapshot of my screen. So I currently drive a 2025 Tesla Model Y. I've had it for over a year now, and you can see that the stats I've put in there, just to summarize, is that I've gone over 25,000 kilometers, and it's cost me a total of just over $1,000 for fuel, which would be charging and maintenance. And the maintenance is skewed because I did a $300 brake service, which is a routine operating maintenance that Tesla asks you to do. But I did it early. I didn't really need to do it in that time. I could have waited another 6 months or so. So if that 300 wasn't done, I would be at 150 for maintenance. But I did it, so I put it on the sheet. So you can see that for that kind of kilometers, most of my charging is done at home, but I do some road trip charging, and those numbers are in there for public, either level 2 or level 3 DC fast charging. So you can see that I have a balance of fuel costs in there for EV charging. And I'm basing that at about 9 cents a kilowatt hour because I do charge overnight when I'm at home, and then whatever the rates are at the time when I'm public charging. And that varies from provider to provider and from time to time. So, what I would encourage you to do is think about how much it would cost for you in gas and maintenance to do 25,000 kilometers and see what it would come up with. And you can see that my operating costs are just over 4 cents a kilometer. And remember that Prius was about 7.5 cents, just under. And I'm almost 50% lower than the Prius, which is kind of the high standard for low operating costs. And in the spring, summer, fall months, when we have some nicer warm temperatures, I can basically do about 400 kilometers of driving for about $5 to $6. It is that cheap because home charging is that cheap. That's something to stress. If we look at some comparisons, then looking at comparing gas cars to EVs and figuring out how much extra they cost and how long would it take for me to recoup that extra cost that I would pay, because we don't have full cost parity yet, i.e., we don't have a gas car and the same version in electric that's at the same price today. EVs still have a bit higher entry point. So you can see here in this example, I've given the Equinox Gas LT and I've given the Equinox EV, and I factored in some basic, some extremely low maintenance costs, just doing an oil change every 10K basically for the first year of 20,000 kilometers a year. And you can see based on that driving, I would recoup the additional cost of the EV, the higher cost, in about 2 to 3 years because I'm saving so much, right? I'm saving $2,700 a year in fuel and maintenance costs. It's a lot of money there. Let's try a different vehicle like a Toyota RAV4 and a Tesla Model Y, right? Same kind of situation, right? Looking at the ranges. Yes, the RAV4 has much higher range. But again, looking at those operating costs, I'm still saving almost $2,000 a year by switching to all electric in these types of environments. Now, again, I'm using just raw numbers. The reality is in the winter, we're going to get lower ranges on all cars, including gas cars. And this summer, we're going to get in the EV range, we're going to get probably even better potentially than some of the EPA ratings. So it does fluctuate on seasonal. But you can see just in a quick comparison that the ROI benefits are still pretty strong, even in those cases. Let's look at the pickup truck market because that's a huge market for Canadian consumers. And if I look at a Silverado work truck versus the EV, finding the model that has comparative range on that, you can see that my ROI model is still pretty strong, right? It's still about 3 to 4 years ROI to recoup the cost of that extra cost for the EV. And then after that, I'm saving, right? That 3,500 a year. And after I recoup those costs, most consumers keep their vehicles for 5, 7, 9, 10 years. I mean, we tend to just put duct tape on them and keep them going for as long as we can. I'm one of those. I like to keep my cars for 10 years and run them down. So I can really start realizing cost savings fairly quickly in these models. I'm going to stop there for a sec. Mitch, was there anything you wanted to add to that?
I cannot, no, not at this moment here, but that's like really good information for us to understand here. Be interesting to see calculations of that 10 years going forward, how much you'd save. So do you have kind of a by year breakdown of savings kind of once you've reached that ROI?
I don't, but I can tell you again that EVs don't have a similar maintenance path that internal combustion vehicles have. So, as internal combustion vehicles get older, there's potentially a lot more maintenance required. Whereas EVs typically don't have that. Brakes will last a lot longer because of regenerative braking. Again, there aren't all those systems that we have in an internal combustion like we have in an EV. Yes, there's an HVAC system, and yes, there's some coolant which might need to be changed, flushed 100,000. There's brake fluid. We still have the same brake system, so if they need to be flushed every 50,000, whatever the manufacturer recommends, then you would look at that. So I would have to go into a lot more detail, but simply put, even if you started to add that up over plus 5 to 10 years, you would still see a substantial saving costs from EVs versus internal combustion.
Okay. We do have one question. I have a feeling you're going to touch
Sure.
on it, so don't skip ahead if you don't have to. But the question is, if I get an EV and want to travel long distances, how
Yeah.
long does it take to charge the vehicle while on the road?
So let's put a pin on that and I'll come back to it. I think
Okay,
I do talk
sounds
about
good.
charging, but I definitely want to answer that.
Okay, perfect.
Excellent.
I'll let you continue.
All right. So I'll keep going. I have one more quick model here. Where we need the financial incentives right now that the federals liberals have come out. And by the way, this isn't a liberal push. I'm not trying to be political here. I'm just stating a fact that our current government has put this new EVAP program, has activated it. And as you can see, when we look at the Toyota Corolla price point versus the lowest EV I can find that meets a similar form and function a vehicle of the Corolla, which is the EV4, utilizing the EVAP, you can see that even with that, it's still a 5 year ROI because we just don't have EVs that are low enough to compete with some of the lower end gas vehicles, the $35,000 vehicles, the $30,000 vehicles, and so forth. And that's one reason that the federal government is opening the door for Chinese made EVs to come into Canada in a very limited fashion. And at some point, starting in year 2 and moving to year 5, we'll see the lower price Chinese, some lower price models come into Canada to offer a very capable solution to consumers that can't afford 45, 50, 55,000 and so forth vehicles to even bring those strong points to make them similar to gas cars from a cost comparison. So I'm excited that we'll see that. But even 5 years isn't too bad when you look at that. I want to touch quickly about safety because it's something a lot of people don't talk about, and to me, it's extremely important. I'm driving my family around in the vehicle. I want to make sure we're as safe as possible. So some of these slides are Tesla focused, but the principle is the same for all the OEMs, the auto manufacturers that build their own EVs from those skateboard platforms that I mentioned earlier. The battery packs that comprise the floor that the chassis is bolted to are heavy. They weigh 1,500 pounds, 1,800 pounds, 2,000 pounds, 4,000 pounds, and maybe the Hummer or something, where they're big, big batteries. So, yes, they're heavy vehicles, but what that adds is a very low center of gravity. You got all that weight that's between the axles on the floor. And race car outlets like F1, they build their vehicles with that in mind. They try to get a low center of gravity so those vehicles stick to the road as best as possible. They're not top heavy. They don't go back and forth a lot and angle out on turns and stuff. They grip the road. Well, EVs have that inherent characteristic just in the nature and the design of these platforms. So what that gives you is not only a handling platform, especially in winter months, they are outstanding in the winter, but a lower rollover risk. Now, it's not impossible to get a EV out of control. If you give it enough power and enough force, you can get anything out of control. But simply put, because of these characteristics, they just offer better handling and they offer safety in the areas of lower rollover risk, especially in pickup trucks and SUVs that have a higher center of gravity. And then because EVs don't have all that stuff like we have in a conventional auto, in an internal combustion vehicle, we have larger crumple zones. We have larger front crumple zones and rear crumple zones. And crumple zones are designed to do what they say. They're supposed to crumple. So here's some videos. This is basically a quick snapshot of the floor of a Model Y. Again, it's easy to find a lot of Tesla pictures, so I just put them up here. But here's what the floor is, and there's a cutaway which showing the cylindrical batteries that make up the floor of the Model Y in this case. That adds to that weight. They're all connected together. There's cooling wires and systems and sensors in there to monitor everything, and then they're all encased in this steel alloy case connected to everything wired up. But because of that, they add increased structural rigidity. Think about it. You've got this pack on the floor combined with some increased structure around the occupants of the vehicle, and it adds to increased safety. Here's the side pole impact test, crash test from the US. It's a very hard test to score well on. You can see you've got this small pole that you're hitting on the side, and it doesn't intrude a lot into the occupants. This looks probably worse. It looks worse than it is. I can tell you that. This is a very much a survivable type of impact because of that increased structural rigidity. And as I mentioned, that larger front crumple and rear zones and the lower center of gravity. Here's a video from Tesla Shanghai just showing some of the components, again, some of the builds on how these things work. A Tesla Model Y, for example, has 60% greater structural rigidity than a similar gas vehicle in its class of type of vehicle. Here's some animations about these things crumpling in. So yes, you might see a Tesla as an example from an accident look terrible. But I can tell you that more times than less, the occupants walk away with very minimal injuries. And the glass roofs on these vehicles, just showing there, can actually hold the weight of two elephants before they start crushing. So they're extremely strong vehicles. And I'm not saying that gas cars like a Volvo or a Lincoln Navigator or a Yukon SUV or something is not a safe vehicle. I'm just stating that inherently, because of the engineering characteristics and the design of these platforms, EVs just have some extended safety benefits because of that engineering. And here's an example of that. It could just be luck, but there's a Model Y that went off a cliff in Southern California back in January of 2023, went down about 250 to 300 feet. As you can see in the picture on the left, it's a very raw area. It was north of Malibu, off of Pacific Coast Highway. The road turned and the car went straight through the guardrail and rolled down. So very rugged, natural situation. You can see, which was interesting, is that the car landed wheels down, which I found very interesting. Maybe it's just a fluke or it's lucky, but I think that the weight of the battery had something to do with that. And then, the EMS had to cut them away, but there were four occupants in that car, two children in car seats in the back. The children had cuts and bruises. The adults in the front had some more serious injuries, but no one had life-threatening injuries in this. Now, that just could be a stroke of luck, but I don't think it's just luck. I do attribute it to some of these advanced safety systems that we have. Yes, there's airbags and there's seat belts and there's all the stuff as well that cars have, which you certainly need to help protect those occupants. But I also believe that the increased structural rigidity and that weight, as I mentioned, in the crumple zones help these people to survive this crash and to be able to walk away from it without any life-threatening injuries. Don't go try this at home though. Here's a quick example I just want you to look at since I've been showing Tesla for a while. This is an EV9, a Kia product. It's their fantastic three-row SUV. You'll see it, the blue vehicle on the center left of your screen. As I'll start this video in a moment, you'll see that it's starting to proceed through this intersection with a black car next to it. You'll see that this vantage point from this camera is coming from a tow truck driver that just happened to be making a left turn and is sitting at the light with his dash cam running. You can see that the middle lane is open, the traffic lights are red, the right lane has a white car there stopped, and of course, the tow truck driver is sitting in his lane. The lights are red the way we're facing because the other traffic have the green light. So I'm going to roll this video and then I'll just explain it briefly to you as well. So So it happens pretty quick, but you could see that the blue vehicle had ran the red light and hit the brakes a bit too late. I'll slow it down for you. So he hits the brakes as he hits the line. He's trying to avoid, starts to turn, but he can't avoid it. He hits the black car. It hits the EV9, tilts it up ever so slightly, and then the driver of the EV9 reacts and just keeps driving that vehicle where the other two vehicles are stopped in the intersection because their front ends are smashed in and they can't move. Here's the damage on that EV9. So it was still drivable, even though it did get towed. It was actually driven up another kilometer up the road for the police to write up all the paperwork and stuff to get it off the main roads. But you can see it wasn't a lot of damage. That impact didn't look that bad, but it was enough again to tilt up this vehicle. This vehicle weighs almost 6,000 pounds. So it was enough force to tilt that vehicle up. I believe that had this been a regular SUV, there's probably a 50-50 chance that it might have been pushed over into a rolling situation. I don't know for sure. I'm not a physicist on that. So I couldn't give you all the energy stuff, but it was a pretty good jolt. And I can tell you that nobody was injured in this accident, even the guy that ran the red light, and certainly the driver of the EV9 was not injured because that was me. This was about a block from home where I was on my way home. And this happened to me while I was driving this vehicle. I was testing a press vehicle at the time, and I didn't even kind of realize that I was in an accident until it just happened. And then I instinctively pulled over and got out, and I saw the car's damage, and I said, "Oh, I think I've just been hit." So again, they're built very solidly and very capably. I want to also, I hear a lot of myths and FUDs, fear, uncertainty, doubt about battery fires and EVs. Of course, when they catch fire, they do make the noise, make a lot of press time because they're extremely rare, and that's why since 2010 and beyond, there's only five, 600 now. That number is a little higher, obviously, in the upper right, but it's only in the hundreds that we've had EV fires for plug-in vehicles globally. We get 100 or so gas car fires in the US a day, never mind anything else. And you can see some of the stats there from Transport Canada as far as the percentages chance. I think you have a better chance of getting hit by lightning than an EV catching fire. When they do catch fire, they're extremely volatile. Usually there's time to get out. They smolder for a bit, then they start this thermal runaway process, and they start burning. And they do burn very hot, and EMS needs to treat these differently, but they're extremely rare, especially when you look at the millions of EVs that are out on the road today. I just want to briefly mention about car theft. It's a little bit less here in Ontario at this point. I'm not sure about some of the other provinces' specs. I haven't seen them, but the main takeaway is that EVs typically aren't stolen vehicles because there isn't a market for them. Car thieves are capitalists. They want to make money on stealing cars. And if nobody wants to buy them, if they can't ship them to anywhere and sell them, then they're really no good to car thieves. And yes, there are sophisticated security systems in EVs. If you cut it the charging cord while they're charging, the vehicle will brick, meaning you have to flatbed it, you have to tow it. But again, the simple fact is that there's not really a market in the areas of the world that stolen vehicles are shipped to. Nobody really wants an electric vehicle. So they're a good way to mitigate car theft. Now, you asked about charging, so I'm going to answer that question. I just wanted to start by saying that there's lots of charging infrastructure in Canada. People feel that there's not a lot. I hear this all the time, and I would challenge people. Uh, Now, maybe in northern Saskatchewan, it's going to be a bit more challenging, but certainly along the major highways in the more southern, mid to southern parts of Canada, as you can see a simplified map of a lot of charging infrastructure. There's over 34,000 ports, and there continues to be more charging added year after year, month after month. Continues to be major investments by the federal, provincial governments of various provinces and agencies, and a lot of private infrastructure. And there's also grant programs for those private infrastructures. To answer the question about how long to stop for a charge, it really depends on the vehicle, the time, the temperatures. There's some factors there. But when you see the auto manufacturers advertise 10 to 80% in about 20 minutes, 30 minutes, 28 minutes, whatever, that tends to be the new norm. Most of the vehicles today have pretty good charging speeds that they're capable of accepting a lot of power, which means the average use, the average wait for a consumer, I would say is about 20 to 30 minutes in a normal stop. You never charge your battery to 100% while you're on a road trip because it just takes too long. It takes the same amount of time to go from 10 to 80 as it does from 80 to 100%. So you wouldn't sit there for an hour or for 45 minutes or an hour 15, whatever it is, to charge that. It just wouldn't be feasible. You could if you wanted to, but most people don't because road trip charging, they don't mind stopping for 20 or 30 minutes. So I'm hoping that that answers your question. And from a charging infrastructure, this doesn't include home charging. So my garage is my gas station. I plug my vehicle in every night, just like I do my iPhone, my iPad, my devices. People ask me how long it takes to charge. I say 10 seconds. I get home, plug it in, go in the house. I come out in the morning, I unplug it, and I leave. That's my charging experience for most of my charging. So if you have the ability to charge at home, the home is your gas station. They're also greener. Now, in Saskatchewan, your power
Kenneth,
generation, go
can
ahead.
I, just while we're on that topic, can I interrupt here? I've got
Yeah.
another related question to that. What makes EV chargers slower or not charge at all in the cold? Is there a preconditioning issue? And I'm just guessing that this might be related to level one charging, but maybe you can speak to that around cold temperature charging.
Yeah, I mean, the physics of batteries is that because of the liquid electrolyte, I'm not going to go too deep because I'm not a physics or an engineer by batteries, but because there is an element of liquid in the batteries cells that separate the positive and negative, and it's the electrons that flow back and forth. The cold impacts that liquid, and that slows down the movement of the electrons back and forth. It doesn't allow as many to go back and forth if the battery is warm. So preconditioning can certainly help advance charging speeds to make them faster, but it's just the simple physics of the way batteries are built today and the cold temperatures. It works the same way on your iPhone, your phones, or your laptops. If they're out in the cold, you'll notice that you don't have as much power available. Your phone dies sooner than it does when it's in the summertime. It's the same kind of principle to that. But there are techniques like preconditioning you can do at home before you leave, or you set a charger as a destination, and most cars now will allow for preconditioning. So it'll heat up that battery so that when you get to the charger, the battery will be at a nice, comfortable temperature to accept the power much more easily and freely. Hopefully that answers the question.
Yeah, and as I understand it too, the different levels of charging, you can charge into a regular outlet as a 110 if you
Correct.
have it at home. And that can work really well if you've got a warm garage. But I have heard from some EV owners that have tried that if they're outside and it's minus 30, minus 40, that a lot of that charge actually goes into just the keeping the battery warm, and they'd actually
Yes.
don't get a lot of that charge, which is why it can be important to upgrade your home charging to a level two, which is basically like a dryer plug or your
Correct.
range, and then that kind of alleviates any of those issues with charging. So,
Absolutely correct. Yeah. Level one is just trickle charge. If you're in very cold climates, you're going to want something a little bit better, just as you said.
okay, great. I'll let you continue on. Thanks, Ken.
For sure. And I'm just getting in the last few slides to almost wrap up. So I just wanted to talk about the
Yeah, I
greener
should
side.
should just kind of check on time here. We're pretty much
Yep.
at
I'm
the
having a
end, and
look.
then
Yep.
we'll get going.
No problem. So just to say that EVs are very efficient, right? About 95% of the power in an EV actually moves the vehicle versus only about 30% in a gas car. There's a lot of waste in a gas car. And as electricity becomes more cleaner, we'll even see greater EV advantages because of how efficient they are. And the key to EVs is especially all electrics is while you're driving them, while you're using them, they emit nothing. So even though there might be a carbon impact hit at the beginning, for the mining and for the manufacturing of the packs and so forth. You can see by some of these points on this slide that when you look at the life cycle of an EV, and that's important, don't just look at one particular part, look at the entire use case of that vehicle. You'll see that because battery packs today are now about 95% recyclable and we can reclaim those minerals, they have a lower carbon impact, even if the energy comes from a coal source. 100% coal burned plant for the energy, they still have about half the carbon impact and then a internal combustion vehicle. And that's kind of the key. There's tons of science on this, so I'm not making this up that prove this out. You look at well to cradle to grave or all these kinds of reports, the life cycle, and you can see even in CO2 emissions, look at coal or oil. Petroleum, uses 4 billion tons for oil production, whereas even for mining minerals globally, it's only 93 million tons. It's a huge difference. So the numbers don't lie. So when people are reporting this kind of stuff, I would always ask you to double check and look at both sides of the coin here. And we're seeing more and more companies in the lower right start up that are into repurposing and recycling battery packs, including the auto manufacturers themselves. And here's you talked about less range in winter, so we did jump a little bit on this one, which is great though. So this chart shows kind of some real miles. You could convert that to kilometers if you want, on where they're operating and what kind of range loss. Yes, it's not uncommon in -30, -40 degree temperatures to see 30-40% loss in the battery. If it's rated at 500, you could be down 150 kilometers. 200 kilometers. That's not uncommon. That's the physics of batteries. Batteries are getting better. There are new chemistries now that are coming out and there's more that are coming that are going to eventually eliminate the cold problem that we have. But even if you have a 500-kilometer EV and you're only driving 50, 60, 70 kilometers a day, even in the middle of winter, it can still be a good thing for you. Again, because of that efficiency on how good they are. And remember, internal combustion vehicles do lose about 30% of their range in the cold months as well. And they take a long time to heat up. There's a lot of waste in idling and getting that heat, where EVs have heat pumps and other systems that start spreading feet in basically a minute or less. It's a remarkable thing. So I'll just end that, EVs have a proven history. They've been around a long time. They just haven't been to mainstream that we see now. Basically, they've been in and out of history for a few different occasions, but they are now mainstream. They do have a lower total operating cost for both fuel and maintenance, the overall strategy. So I would encourage you to look at those kinds of things. They're very easy to operate. You don't have to worry about cranking power in an EV because there's no motor to crank, there's no starter to crank. They just turn on like a light switch. As long as they do have 12 volts, so you do need the 12 volt to be in good working order. As long as that 12-volt system is working, your EV will start, quote unquote, and will start heating up and working. And there's good charging, they're very safe, and they are very clean for the carbon impact. So that's some of my information. You can reach me at evrevolutionshow@gmail.com. I'm also on Twitter or X at evredshow, and you can find me on Google and the audio quite easily. And then lastly, again, I'm part of EVS, a volunteer group across Canada. We have chapters across Canada. We are all nonprofit volunteers, and we do a lot of education for consumers. And I think I'm going to turn it back to you, Mitch, because that's the end of my slides.
Great. Well, thanks so much, Kenneth. I know we could talk for hours on this stuff, but we unfortunately are running short on time. And I just want
Good.
to, in case some people have to jump off, just want to make sure that we talk a little bit about our next session here. So let me just take that slide show over here again. Does everyone see my slides all right? Can you see that
Okay.
now?
I do have time to answer a couple questions. I do see one here that we haven't talked about, but I'll let you finish,
Perfect.
Mitch. Yeah.
Yeah, I just want to let, in case people have to jump off
Mhm.
here, our next episode will be Wednesday, April 22nd, and we've got some EV owners in Saskatchewan that are going to speak about their EV experience and give some testimonials on their experience of owning EVs in Saskatchewan. So we've got Sask EV board member William Hale, president of SEVA, Saskatchewan Electric Vehicle Association, Matt Pointer. We've got Mike Rogers with Aurora Renewables and Frank Deck, who is a Silverado EV owner, and then he uses that to haul water to his community. So looking forward to hearing from that group next month. Also want to take a moment here for anyone that might be interested in learning more about EVs. One of the premier EV events in Canada is taking place in a couple weeks on April 8th to 9th in Toronto. There's EV Charging Expo 2026 brought to us by our friends at Electric Autonomy Canada. If anyone in Saskatchewan as a Saskatchewan resident is interested in this event and would like to sign up, please give us a shout. Send an email to us at Aurora, and we can talk about getting you a discount rate for that event. So we've been given a discount code for Saskatchewan residents for this event. And then, yeah, let's jump back into a couple of the questions here that we might not have got to. So one on the screen here is, what are some of the other leading brands in EV besides Tesla? And do any other companies make better vehicles in terms of range and recharge rates?
Yeah, it's a great question. There are lots of great choices I mentioned earlier for consumers. GM, General Motors, has a lot of different brands within their Chevy, their GMC, and I'm forgetting the other one now. But in their Cadillac brand, sorry. So they can vary on ranges, but a lot of them can be better than the Tesla ranges and support fast charging speeds as well. The South Koreans have done amazing things with their electrified technologies and their platform-based products. They offer some 800 volt architecture units like the Ioniq 5 and 6 from Hyundai, the Ioniq 9, the Kia EV9, the Kia EV6. They have other models as well, but when you get into 800 volt architecture, you're talking about fast charging speeds. They can pull 350 up to 350 kilowatts. And have some longer range products as well. So there's a lot of great choice. Volvo, Polestar, some other options that come from through those brands that are basically Chinese owned through Geely as well. Ford has kind of taken a bit of a step back as they discontinued the F-150. The Mach-E, though, is still a very nice product and a nice platform. Toyota has launched some new EVs this year, so they're starting to get into the all-electric space much more seriously. And of course, in conjunction with Subaru, because they share platform designs, and Lexus, so they have some similar products coming out now that'll be available. So pretty well everybody, with the exception of Honda, Mazda, they're kind of the brands that are lacking. Honda's pulled back from the electrification space. And Mazda hasn't really done anything from an all electric. And they have a few plug-in hybrid options, so there are some plug-in hybrids. And then the Germans, the BMW is going full tilt into electrification. Same with Mercedes. They're just rebranding. Audi has a large platform base, as you saw some pictures earlier. So there's a lot of product out there.
Great. Yeah, thanks. What do you drive, Kenneth? What kind
Yeah,
of
so I
vehicle?
have two vehicles. We have a Tesla Model Y, and we also have a 2023 Kia Niro EV, a smaller one, and we love them both. The Niro is actually quite a great EV, which we can get pretty good range, in excess of 400 kilometers in the summer, 450 almost, and it's a great, comfortable vehicle. So yeah.
Right. One of the other questions that we had from uh, previous to the recording here is that we've
Mhm.
got, do you have any experience with backup power supply, using your EV as a backup power supply?
Yeah, it's a great question. I don't have any personal experience. I have tried the vehicle to load technologies, which mean that some manufacturers will offer you the ability to take power from that battery in the car and use it like with a 110 extension cord or a plug to plug in a light or a kettle or a radio or a TV or whatever. So there's that concept. That what you're talking about more like vehicle to home, like a power backup for your home, I guess, application, vehicle to home or even vehicle to grid. It depends on the manufacturer who offers that. A lot of the manufacturers that do offer bigger battery solutions will offer vehicle to home, but I haven't experienced any of that. But that is there where you're in essence your pickup truck, as an example. If it's an F-150 or a Silverado, it can back up the power for your house for 2 to 4 days.
Right. Great. Sounds good. Kenneth, unfortunately, we are running out of time.
Yeah, I know. No
I would
problem.
love to keep you a little bit
Yeah.
longer and answer some more questions. To our audience here, we would, if you can, please fill out our survey here so we can learn about how you found us today in our webinar and make sure that we can promote this through the appropriate channels. So please fill out the poll that's on screen. Um, Kenneth, I can't thank you enough for taking the time today and putting all this information together for us and sharing it with us. Your passion and your knowledge of the electric vehicle space is truly inspiring. So I can't thank you enough for that. And I hope that we can maybe have you back for some future episodes and dig into maybe a little bit deeper on some of the vehicles that are out there, because
Yeah.
I'm quite certain, and I have no official, but I'm pretty sure that you have driven more electric vehicles than anyone that I know. So
Yeah, I've
you
got over
definitely know your stuff.
270 episodes, so I've driven a few, yes.
Yeah, so make sure to,
Yeah,
if anyone's interested, to check out the EV
thank you.
Revolution show, the YouTube. I have definitely been going through it to kind of do virtual test drives of all the vehicles that you've had the pleasure of test driving, and you do an excellent job in that. So thanks very much.
Thank you.
And thank you to everyone for joining us and participating. We hope to see you all next time on April 22nd to learn more about the Saskatchewan experience of EV ownership. So thanks again for tuning in, everybody, and have a great evening.